This video is on accuracy and precision, kind of what they are and their differences, and kind of how it relates to our science class. So first, what you need to understand is that measurements are always uncertain. So we always have a level of uncertainty to our measurements, and that last digit is usually the one that's the estimate. So this is different from math class where you're just looking at numbers as just pure values. Here we're looking at them as measurements. So an example of this would be if I had, let's say, a graduated cylinder. You might want to draw this. All right, and this is maybe 10 milliliters onto my cylinder. And I have 1, 2, 3, 4, 5. 1, 2, 3, 4. So then up here, this would be 11 on mine. So you can see each marking on there is worth 0.1 milliliters. So if I had my water, it would look something like this. And if you remember, you're going to see that curved line. That's going to be our meniscus. So when you're reading this, you read the bottom of the meniscus. And I'm going to say, well, it looks like it's right about 10.5. So I might record this as a volume of 10.5 milliliters. But here's the thing. It could be as high as 10.6 and it could be as low as 10.4 because that last digit is actually my uncertainty. That's my estimate. And you can actually see, like, it looks like from my drawing, it's a little bit below. So we'd actually carry it one more digit. So we'll get to that more coming up. So, what is accuracy actually? Well, it's how close you are to the correct or accepted value. There are times where we will collect data in a lab and we will, or an experiment, and we will find, let's say, like the density of something, and we can compare it to the actual density of that substance if it's something we could look up. Precision, however, is how close you are, all of your measurements are to each other. So when you're doing labs, we do multiple trials because we want to see, are we being precise? Are we getting the same results every time, kind of in that same range? So kind of the common example is this bullseye example that you have on your paper in your notes packet. So first, looking at this, something that's precise and accurate would be this one. So if you are throwing darts, accurate would be they are all in the bullseye. So the bullseye is accuracy. So right in here. Oops. Right in here. But it's also precise because all of your darts are close together. So in this, so we'll call that box 1. In box 2, however, we have a very precise set of darts. They are all close to each other. They are similar. However, they are not accurate because they're not in the bullseye. So in box 3, we have some accuracy here. We've got 3 in the middle. Okay, and the other ones are close. However, when you compare them all to each other, they are not precise. So we have accuracy but low precision. And this last one, in 4 we'll call it, you've got kind of markings all over where your darts hit, and they're not necessarily all over close to your bullseye. So this is neither accurate nor precise. So something to think about in science is that we want both. So there are things we will do in our lab to help control this. There are things we will make sure we note on how precise we are. And there are calculations we'll do to kind of check our work, see how we're doing. So this will apply a lot to our labs. Yeah, that's accuracy and precision.